Modernage MCQs Physics first year, Unit number 5, Rotational and Circular Motion, Part 4. A solid cylinder of radius r is rolling on a horizontal plane with speed v. What is the translational kinetic energy of cylinder? Option A, mv square. Option B, 1 by 2 mv square. Option C, 7 by 10 mv square. Option D, 10 by 7 mv square. The key is 1 by 2 mv square. Therefore, the correct option is B. Reason: when solid cylinder rolls on a horizontal surface, the translational kinetic energy is kT is equal to 1 by 2 mv square. Hence, the kinetic energy of solid cylinder is 1 by 2 mv square. A hoop of mass m and radius r is rolling with energy E on a horizontal plane. If the speed of hoop is v, then its translational kinetic energy will be option A E, option B 0.5 E, option C 0.4 E, option D 0.7 E. The key is 0.5 E. Therefore, the correct option is B. Reason: the translation kinetic energy is kT is equal to 1 by 2 mv square, which is equal to 1 by 2 m into r omega whole square, or kT is equal to 1 by 2 into m r square into omega square, which is equal to 1 by 2 I omega square, where mr square is the moment of inertia of hoop, which is equal to kr. Therefore, kt plus kr is equal to E, or kt plus kt is equal to E, or 2kt is equal to E, or kt is equal to E divided by 2, which is equal to 0.5 E. Hence, the translational kinetic energy of hoop is 0.5 E. A hoop of mass m and radius r is rolling with energy E on a horizontal plane. If the speed of hoop is v, then its rotational kinetic energy will be option A E, option B 0.5 E, option C 0.4 E, option D 0.7 E. The key is 0.5 E. Therefore, the correct option is B. Reason: the translation kinetic energy kT is equal to 1 by 2 mv square is equal to 1 by 2 m into r omega whole square, or we can write it as 1 by 2 m r square into omega square, where m r square is the moment of inertia of hoop. So this is equal to 1 by 2 I omega square, which is the rotational kinetic energy. Therefore, the translation kinetic energy plus rotational kinetic energy is equal to E, or rotational kinetic energy plus rotational kinetic energy is equal to E, because translational kinetic energy is equal to the rotational kinetic energy. Therefore, 2kr is equal to E, or kr is equal to 0.5 E. Hence, the rotational kinetic energy of hoop is 0.5 E. Note: the moment of inertia of hoop, which is also a ring, is therefore for rolling hoop half of the total energy is translational kinetic energy and other half is rotational kinetic energy. A spherical body of mass 1 kg and radius 2 meter is rotating about an axis passing through its center with moment of inertia. Option A plus 1.6 kilogram square meter, B plus 0.8 kilogram square meter, C minus 1.6 kilogram square meter, D minus 0.8 kilogram square meter. The key is 1.6 kilogram square meter. Therefore, the correct option is A. Reason: the moment of inertia of a spherical body about an axis passing through its center is I is equal to 2 divided by 5 into m r square. Therefore, I is equal to 2 by 5 into 1 into 2 square, or I is equal to 2 by 5 into 4, which is equal to 1.6 kilogram square meter. Hence, the moment of inertia of spherical body is plus 1.6 kilogram square meter. A body of mass 2 kg is suspended from the ceiling of an elevator moving up with acceleration 9.8 meter per second, its apparent weight will be option A 4.9 Newton, B 9.8 Newton, C 19.6 Newton, D 39.2 Newton. The key is 39.2 Newton. Therefore, the correct option is D. Reason. The reading of spring balance as the elevator moves upward with acceleration A is W is equal to M into G plus A as the elevator moves up with acceleration A is equal to 9.8 meter per second. Then the apparent weight of the body is W is equal to 2 into 9.8 plus 9.8 which is equal to 2 into 19.6 which is equal to 39.2 Newton. Hence, the apparent weight of the body is 39.2 Newton. A wheel of radius r rolls on a horizontal surface. In two rotations, it covers option A pi r meters, option B 2 pi r meters, option C 3 pi r meters, option D 4 r meters. The key is 4 r meters. Therefore, the correct option is D. Reason. Formula S is equal to R theta. In this problem, R is equal to capital R and theta is equal to 2 rotations R. Theta is equal to 2 into 2 pi radians, which is equal to 4 pi radian. Therefore, wheel covers S is equal to R into 4 pi, which is equal to 4 pi R meters. Hence, the distance covered in two rotation is 4 pi R meters. A sphere of mass 2 kg and radius of 10 centimeters is rolling on a horizontal surface with uniform velocity of 10 meters per second covered a distance of 20 meters. The rotational kinetic energy of the sphere is equal to option A 20 joules, option B 40 joules, option C 80 joules, option D 100 joules. The key is 40 joules. Therefore, the correct option is B. Reason. The rotational kinetic energy Kr is equal to 1 by 2 I omega square, which is equal to 1 by 2 into 2 divided by 5 mr square, which is the moment of inertia of the sphere, into V divided by R whole square R. Kr is equal to 1 by 5 mv square. Therefore, Kr is equal to 1 by 2 into 10 power 2, which is equal to 40 joules. Hence, the rotational kinetic energy of sphere is 40 joules. A lead ball of mass 2 kg, radius of 10 centimeter and velocity 10 meters per second is rolling on a horizontal surface with translational kinetic energy. Option A plus 100 joules, option B 50 joules, option C minus 100 joules, option D minus 50 joules. The key is 100 joules. Therefore, the correct option is A. Reason. The translational kinetic energy of lead ball is kT is equal to 1 by 2 mv square or kT is equal to 1 by 2 into 10 power 2, which is equal to 100 joules. Hence, the translational kinetic energy of lead ball is 100 joule. A football of mass m, radius r, rolling on a horizontal surface with uniform velocity of v possesses energy. Option A 7.0 mv square, option B 0.7 mv square, option C 5.0 mv square, option D 0.5 mv square. The key is 0.7 mv square. Therefore, the correct option is B. Reason. The total energy of football is E is equal to translational kinetic energy plus rotational kinetic energy, which is equal to 1 by 2 mv square plus 1 by 2 I omega square, or E is equal to 1 by 2 mv square plus 1 by 2 into 2 by 5 mr square, which is the moment of inertia of the ball, into V divided by R whole square, which can be written as 1 by 2 mv square plus 1 by 5 mv square, which is equal to 7 by 10 mv square, which is equal to 0.7 mv square. Hence, the energy possessed by football is 0.7 MV square. A cricket ball of mass m, radius r is rolling on a horizontal surface with uniform velocity of v. The ratio of translational to rotational kinetic energy during the motion will be option A 2 to 5, option B 5 to 2, option C 1 to 2, option D 2 to 1. The key is 5 to 2. Therefore, the correct option is B. Reason. The translational kinetic energy of cricket ball is kT is equal to 1 by 2 mv square, and its rotational kinetic energy is kr is equal to 1 by 2 I omega square, which can be written as 1 by 2 into 2 by 5 mr square, which is the moment of inertia, into v divided by r whole square, which can be written as 1 by 5 mv square. Therefore, the ratio is kT divided by kr, which is 1 by 2 mv square divided by 1 by 5 mv square, which is equal to 5 by 2. Hence, the ratio of translation to rotational kinetic energy is 5 to 2.